So JCloud was one of the main driver behind enabling hybrid clouds, because they can support multiple cloud providers. So you can use JCloud to create hybrid cloud. So pretty much your application works with JCloud, and using JCloud you can deploy application on Amazon, on Rackspace, on Azure, and it also supports Docker. So you can use JCloud to program your Docker-based application as well. And from JCloud, you can actually configure your Docker Swarm oval networking as well. So now you see how it's two-level. You use JCloud to enter Docker, and then use the JCloud Docker Swarm driver to configure your Docker oval networking. But you can also use the same JCloud to configure Amazon data center networking as well. So this is very nice and abstract way to use JCloud to configure different cloud providers and different networking provided by different providers. So what was the advantages of this multi-cloud API? The first advantage was application portability. So because you have now a code base that is able to interact with multiple cloud providers, multiple virtual hypervisor types, that can one be based on type 1 hypervisor, type 2 hypervisor, or Docker. So it gives you a very nice way to deploy your application on different kind of environment, as long as inside those VMs you can have the Docker. So then you can have one application running on pure Docker and other running on Amazon, which is running inside the virtual machine. So it gives you very good application portability. It could also improve performance. It depends on what you mean by performance. Of course, if it's your gaming application or video on demand application, so you can always deploy your application logic near to the user, so you can improve your network performance. It improves your cost optimization, because you can always choose the cheapest on the fly, because you now have a code base which is helping you to deploy application across multiple providers. So based on their dynamic pricing, you can also migrate your application instances as well to optimize your cost. So this is only possible through a cloud API that helps you program a different cloud at the same time. And since you're able to deploy application on multiple clouds, avoids a lock-in, so you're not dependent on just Amazon or Microsoft or Google to run application. You can run on any number of providers. So it, of course, as I said, it helps you in creating hybrid clouds, as well as it eases the issue of application migration that we thought was a bit difficult, because every time you want to migrate your application to the next cloud, you need to understand how do you orchestrate, program that cloud. So if you use JCloud, that thing is simplified. So these are the main. So as I said, JCloud supports more than 100 cloud providers, but these are some of the main which is popular in the enterprise domain, like Amazon Web Services, HP Cloud, Google Cloud, Microsoft Azure Cloud, Docker Cloud, OpenStack, and so many. So you can create hybrid cloud, or you can just create multi-public collection of multiple public cloud using the JCloud interface. Can you do the same just by using Docker APIs? So JCloud gives you this adapter. Does Docker SDK do the same? Can I create multiple cloud providers just on Docker? Only if they are at the entry source, they are using Docker daemon, right? If each data center is managed by pure Docker, then I can connect multiple data centers just using Docker API. But that's not the case. Most of the providers, they hide the Docker daemon behind the hypervisor. That's why this multi-level things come into picture, and that's why we need to use JCloud. If everyone is just using Docker-based installation to manage the data center, then you can just use the Docker SDK for Python or Java to connect to multiple data centers. But normally they don't do it for security. And also, not all workload can be moved to Docker. Some of the old legacy workloads still needs to run on virtual machines. So they still need to support hypervisor-based virtualization along with the Docker-based virtualization. That's why they need to support both the interfaces. So that's why they will never purely go on Docker or purely go on the hypervisor. They always will have a mix. And that's why the deployment and networking becomes an issue. So this is one snapshot of how to create instance of a virtual machine in on Amazon EC2 Cloud. So this basically says that if you want to configure a virtual machine using JCloud on Amazon EC2, you have to configure which data center you want to go. So first is so you want to go on the Amazon EC2, then you have to give your access key ID and secret key. This is your access credential to the Amazon Web Services. Then you have to say, get the list of images. Then you have to say which kind of OS, what kind of security group, what kind of key pair, what kind of web server you want to run, and then after that you can fire those. So one thing to understand here is, although this JCloud API abstracts the features of Amazon and Microsoft, but the way they do, for example, their security may be different. So like the security group and the key feature for Amazon may not be compatible with Microsoft or Google. So even if you can use the JCloud, you should need to understand how they implement their security. You just can't use the same code as it is copy paste and run on the Azure cloud as well. You have to change the security features, for example. You have to change, for example, which kind of cloud data center URL they provide. For example, what is the image repository? For example, not all cloud providers use the same VM image repository. They will have different. So still you need to find those extra metadata before you can use JCloud as well. So you see, although this is abstracting a lot of things, still you need to learn a lot of knowledge on security and the VM management to be able to use the JCloud for creation of the same virtual machine instance across Amazon or Azure. Because every data center, unfortunately, they implement the security in a different way. And that complicates a lot of things, how you create your virtual machine on them. Did anyone from this, they use JCloud for Docker for your coursework? No. So you can try this as well. For example, many things try, but then again, we have limited time. So if you have, so you can use this code to connect to your Docker daemon and create Docker instances. Why it is good if you do that, you can use the Amazon code to create Amazon and you can try on both of them. But of course, we have limited time. But again, it just gives you more understanding how one SDK can be used to interact with both Amazon as well as the Docker, and gives you understanding of those features. Right. So if I want to use this JCloud based integration for microservices, what is the problem? So I can use JCloud to create microservice instances. So what is the problem with that if you want to really run massive scale application infrastructure like say Amazon Bookshop or something like that? What's the problem with that? So I'm able to create instances, deploy it, run it, network it somehow. But what is the problem with that in terms of if you're an application engineer? We need one more level above that. So before we go into that, so I create many microservices using that, but what is the problem with managing those microservices just with a JCloud interface? It's agnostic to microservice, right? It doesn't know what's inside the microservice, right? So we need some networking feature, at least at the application level, which is not agnostic to the behavior of microservice. So as we studied in the container lecture, that microservice is the fine-grained decomposition of a monolithic code, and each of the microservices has a specific role to play, right? And as compared to monolithic code, you end up many instances of microservices because of decomposition, and then if you just network them together without the context, it becomes very messy and very hard to manage when the microservices move from one host to another host based on the updates and scalability. So what could be a solution for that? So we need one more higher level of networking. And that's something called the new pattern called the API gateway pattern. It's more like a choreographer for the microservices. So if you can draw parallel from this music choreography where we have the one master guy who is coordinating how microservices are behaving. So if you want to design a microservices based application, deploy on the cloud for production environment, you have to implement an API gateway. This is one level higher than JCloud and Docker Swarm networking. Okay, so this works on top of Docker Swarm networking, and this has knowledge about the behavior of the microservices. It doesn't actually care about the VXLAN driver or the tunneling used by the overlay. It's done it's assumed it's done internally by the Docker. So as I said, if you just use a Docker Swarm overlay or JCloud, it will create an agnostic infrastructure to microservices. And that infrastructure will not care about different needs of client. For example, say someone is using your microservices from mobile phone as compared to the laptop. So they have different browser settings, different formatting requirements, and different amount of information that they want to display. But if you use just the traditional networking and traditional load balancer, you can't differentiate between the mobile client and the desktop client. So this leads to not very efficient microservice infrastructure. So to overcome, and what happens in that case, based on if you are networking or microservices agnostic to their behavior, the clients end up sending requests to each of those microservices, and it just leads to more latency because the client has to send more messages to the application, as well as the round trip delay increases. So to overcome that problem, they have come up with a solution called API Gateway, where API Gateway gets requests for the client and it understands what are the needs of the client. For example, if his client is on 3G network or 4G network, it sends them to a different microservice. If the client is on internet, WAN or LAN, it sends them to other network. If the client is API, it's sent to different microservice. So based on the context of the client and the needs of the client and the device of the client, the API gateway sends the request to different set of microservices. So this is one example. For example, so API gateway is a single entry point for all your clients to your microservice infrastructure. So the role of API gateway is two things. First is can be a traditional router where you get a request and send to some microservice. And second role could be it multiplexes a request from the client and creates multiple other requests to different microservices. Just to give an example, say if you go to Amazon Bookstore application, you want to know the name of the book and their prices, and this might be in two different microservices. So if you send that request to that API gateway, it can create two requests. If there was no API gateway, the client has to send two requests separately, and the request will go back. So you just, by having API gateway, you cut a lot of network messages. Also, it simplifies the implementation of services. Since if there is no API gateway, and those microservices need to talk to each other, what happens in that case is that those microservices need to be aware of their ports and the IP address. And if during a network reconfiguration, if your port and IP address changes, you have to go and again update the microservice code as well with the new configuration. So that becomes really hard to manage with a large infrastructure. But if you had an API gateway, you can do all those port mapping as well as IP address update just in the gateway, and then the microservices don't need to be aware about the change in the network configuration. Yeah?
Is that like something like a DNS server or something similar?
It's one layer, similar to that, but one layer above that, so that the microservice doesn't have to care about which port I need to send this message. Just can ask the API gateway where to send. So because why it is required? Because in microservices we have a lot of decomposition. One monolithic code is into maybe 10 small components, and then managing individual networking on that becomes really tough for network administrator. That's why API gateway can abstract those things. And if your application it wants to serve some static content, so that can just be cached at the API gateway itself. It doesn't have to be in the source. So it simplifies a lot in terms of application architecture. Not only that, you can implement the authentication to your microservices, you can do traffic control, you can do the monitoring across microservices become very easy because you can log everything from the gateway itself. You don't have to monitor across each microservice. You can do some extra transformation, you can do some extra encoding. So it gives you a lot of control on how you interact with the client as well as how you interact with your microservices. And based on this pattern, there's one more pattern emerging. It's called backends for the front ends. It's quite funny, but this is the new other pattern for the microservices. So, so what this pattern does is it is an extension of API gateway. What it does, it creates a separate gateway for each kind of client. So you have a separate gateway for mobile application, a separate gateway for web application, a separate gateway for third-party API application. And then if you design your application based on this backend for the front-end pattern, it becomes really easy for you to network manage your application for needs of different clients, because these days, as you see, people are using standard desktop-based browser as well as mobile app. So you need this kind of abstractions or patterns to create more easy to manage and agile microservice-based applications. So of course, as I said, using this kind of patterns to integrate your microservices has a lot of advantages, because it insulates the clients from understanding of how application is partitioned across microservices. It avoids the round-trip delays from API from the clients to the microservices and the back. And also it's easy for your scalability and other things. Having said that, adding API gateway to application leads to more complexity, because it becomes one more dynamic moving target of the application, and it leads to more work for development and networking team. So of course it gives you good nice features on how do you manage your application infrastructure, but also leads to new complexities in terms of management of networking and deployment team. And then every time there are changes in the microservice configuration in terms of ports and IP, that has to be reflected to API gateway as well. So yeah, so it has this positive, but also it has the negative. And then again, when to use your API gateway, when not to use API gateway, you will learn by having experience in working in that domain, and you can reflect upon that. So it's Friday, he's already leaving.
Oh, the train. Sorry about that.
We just have 3 more slides, we all can go. Right. So API gateway pattern is good for those integration that needs real-time integration between the clients and the microservices and the APIs. But there are some scenarios when there is no need for real-time integration. So even a late integration or eventual consistency or lazy consistency is permitted. For those kind of microservices application, you can use something called message brokering style. You can use message buses, message queuing system like RabbitMQ, Azure Service Bus, and this. So these pattern also sends messages from one microservice to other microservice, but it's not in real time. It's based on eventual consistency. So what happens in this case is all those microservices which is interested in certain event from other microservices, they register on a topic to the message broker. And those microservices publish the information to the message broker, and when those topic match happen, the subscriber gets the information. For example, say you have inventory microservice and the accounting microservice, or say pricing microservice. So the inventory microservice is interested in to know the pricing of a product across different providers. So inventory microservice can subscribe and say, let me know the new price when it changes. So you can subscribe for that event, and the accounting microservice, whenever it gets the push from the external API that the price of certain product has changed, it is published there, and that's notified. So, but it's not in real time. It's done in eventual consistency way, but still it works. So based on how urgent is the application, how urgent it is for you to share information, you can use this way as well to integrate your application. And again, to keep in mind, this works on top of your Docker Swarm over networking. This is working on top of that. That's low level in networking. This is mainly much high level at the level of microservices. So as I said, when you want asynchronous messaging between microservices, this message brokering is much suitable approach as compared to the API gateways. But one of the downside is that it is not real time. One of the good side of that is that it can integrate different platforms, different programming languages, different communication protocols. So it gives you a lot of advantages. Right. So today we learned quite a few ways to network your application. That includes bridge, host, overlay, JCloud, API gateways, and message brokering. And of course, which one are you going to use is based on what microservices are using, what is the scale of your infrastructure, how big is your networking development team, and based on that, you've got to decide which kind of networking you're going to use. So it's a complicated topic, but you need all this knowledge in the back of your mind to be able to decide which networking is best for me, because that's networking is one of the critical part of your application infrastructure. Without that, you cannot offer your application to the outside world. With that, we'll close today's lecture and see